Hello. So, as far as I covered two different types of matrices, right? The very first one is occurrence matrix, and the very next one is co-occurrence matrix. And within the co-occurrence matrix, there are other two different types or different ways of creating the co-occurrence matrix, that is based on the occurrence context, and the second one is based on the skipgram method. So, what are these occurrence matrices or co-occurrence matrices? So, we are creating these matrices to feed into the deep neural network, right? So the input to the neural network would be generally in a numerical form and we consider that numerical forms as vectors. So these occurrence matrix and co-occurrence matrix are generally clubbed under a single umbrella called as word vectors. So matrix are indirectly a representation of vector. So let us compare on both hands the two different vectors we studied, that is occurrence matrix and co-occurrence matrix. So on the left hand side I am taking occurrence matrix and on the right hand side I am taking co-occurrence matrix. So we can also refer them as occurrence vectors or co-occurrence vectors, right? So the very first difference would be the shape of the matrix. So occurrence matrices are created using sentences or the context as columns, whereas the words or terms as rows, right? So as a given example, generally the matrix will be looking like there are different sentences, but we have only few words to compare with. So the number of rows will be lesser than the number of columns. Hence, it is general intuition that it would be shape of rectangle. So that's why the shape of the occurrence matrix will be generally rectangular matrix. But when it comes to co-occurrence matrix, it will be in the form of square matrix, right? Because we are trying to create the co-occurrence matrix using term pair, right? So here the columns will be taken as terms and even the rows will be taken as words or terms. So that's why the matrix would be generally square matrix. Then other major difference, as I already mentioned, the rows of these matrices will be terms, whereas the columns will be context. Context refers to sentence, document, term, or the entire sentence, etc. Whereas the columns in the co-occurrence matrix would be terms itself again, right? So the last difference would be the different types of model or the examples. So in the occurrence matrix approach, we are creating one type of vector or one type of methodology called as LSA or latent semantic analysis. And whereas in the co-occurrence matrix, we are trying to create very popular word vectors which are generally used in sentiment analysis or semantic analysis based solutions. We will be using these vectors, that is word to vec and glow vector. I am going to explain about LSA, word to vec and glow in the further sessions. So moving further, what does these word vector say about, right? That's the question that will be pinging to our head, right? So why are we creating? So what are these word vectors help us in in getting the solution? So word vectors generally says about differences or the similarities between given any two terms. In the previous two approaches, we are trying to correlate some relation between two different terms, right? So the thing is, like in the occurrence matrix, we are trying to create the relation between a term and a document, whereas in the second approach, we are trying to create a correlation between a word and a word. So what exactly this vector say about? So they will say about the differences and similarities between two given terms based on their occurrences, based on their context. So the very first thing what we are going to learn about the differences or the similarities between a term using a LP norm. So the LP norm will give us the similarities between or the differences between a two term. So for say given term T1 occurring with different frequencies, right, like Fi1, Fi2, etc. up to fin, and say another term t2 or tj will be appearing with the frequencies fji, fj2 and fjn. So given two terms, if I going to get the similarity or the differences, I am going to get a score using this formula where it says p root of summation of k, that is k equals to 1 to n, that is number of terms, so the number of frequency or the number of iterations which I am going to conduct, then p root of that and summation from k equals to 1 to n, then absolute difference, right? That's why I'm using this modulus term. So the absolute difference between the given terms frequency to the power of p, pth power of absolute difference between the frequencies of a given term in two different contexts. This will give us the value. If the value is very high, say the LP value is some 1.5 and for given two term, and the for the given two other terms, if the LP value is 0.5, then we could generally say that the two terms with the highest LP value are more similar when compared to the 0.5 value, right? So this p power will generally indicate two different kind of distances. That is, if the p equals to 1, then it is a Manhattan distance. If p equals to 2, then it's an Euclidean distance. Generally, we will take Euclidean distance as a standard measure. So we will be assuming p equals to 2 and compute the LP norm formula. There is another way of getting the similarities or the dissimilarities between the two vectors. That is cosine similarity. This is one of the widely used approach or the measure to term or to know the differences or the similarities between given two words. So the cosine similarity is nothing but the dot product of the two frequencies of the two vectors given divided by the magnitude of the terms frequencies of the two different vectors. So it is generally defined as summation from k equals to 1 to n of two different frequencies, say f1 fik dot fjk divided by the magnitude of each frequency of these terms. So here you could see the summation from k equals to 1 to n, then frequency square. This is square because, as I mentioned, we are going to assume the distance as Euclidean distance. That's why we are going to consider this power peak power as 2. So that's why f square ik into summation of k equals to 1 to n, then f square j k. So j is another term's frequency and I is another term's frequency. So when I divide the magnitude, then I am going to get a cosine value. So generally, since the terms frequencies value, see, you could see in the table, these 1 0 will be generally representing the terms frequency, right? So these terms frequencies would be positive value, right? There will be no negative values in the terms frequency. There will be not like so this word is appearing minus 10 times. No, that is not the case. That's why, so the values of the frequencies will be a non-negative value or positive value. So that's why the cosine value will be ranging from 0 to 1. The range is between 0 to 1, which indicates if the value is 0, then the two different words or the two given different terms said to be highly different. If the cosine value is 1, then those two terms are referred as similar to each other or similar terms. So this is about the word vectors and why are these word vectors considered and what does these word vectors say about and what are all the two different approaches we will follow in order to understand the differences or the similarities of given two terms within a context. So in this session, I am going to comprehend the overall learnings of the word vectors, right? the word vectors and the similarities, everything. So in this session I'm going to comprehend on the word vectors with the classical example. So I have taken one of the dialogue from Harry Potter movie. So this is a example of that, right? So this is a sentence or the paragraph which I have taken. So sorry, he grunted as the tiny old man stumbled and almost fell. It was a few seconds before Mr. Dursley realized that the man was wearing a violet cloak. He didn't seem all upset at being almost knocked to the ground. So this is a paragraph which I have taken from a Harry Potter movie. Now let's assume that our vocabulary only contains few words as listed below. That is, vocabulary indicates the words which have meaning after removing the stop words. So here the stop words would be say sorry, he, as, the, etc. So I have taken few vocabulary words after removing the stop words and punctuation. So I am left with few vocabulary words, that is man, stumbled, seconds, Dursley, man, clock, upset, knocked and ground. There are other vocabulary words as well, but I am going to take the first few vocabulary words. Now I am going to create a co-occurrence matrix using this. So even while creating the co-occurrence matrix, there are two approaches, right? So one is occurrence context based and second one, that is skip gram method. So I'm going to follow 3 skip 2 gram method to create the co-occurrence matrix. So I have taken man, stumbled, second, Dursley, clock, upset, knocked and ground. Now I am going to create a co-occurrence matrix using 3 skip 2 gram. So before creating this 3 skip 2 grams, we have to generate a pairs, right? So based on the sliding window, I have to create a bigrams. So this is how my bigram look like using the two different sentences which I have concatenated here. So I have created this entire bigram based on 3 skip 2 grams method. So now I am going to create the final co-occurrence matrix, which will be looking like this. So I will be like pairing or mapping each of the words on the left hand side and similarly on the right hand side. Based on the pairs which I have created, I am going to match one if there is a pair with those words. If there is no pair about those words, then I am going to mark it as 0. So let's say an example of man and stumble. Okay, there is a word stumble, there is a word man. So there is a pair which exists, man and stumble. So I'm going to mark it as 1. So if I take another example, so stumbled and upset. So I'm going to search where there is a word stumbled and upset. Clearly, there is no such pair, right? Stumbled and upset are not going to co-occur together. So that's why I'm going to mark it as 0. Similarly, I have created this entire co-occurrence matrix. So this comes to an end of word vectors. Thank you.